Seagate is going to talk about head depopulation in the field, which is one way to keep devices going in the field. So Curtis.
Morning, everybody. My name is Curtis Stevens, and I'm here to talk about offline head depopulation. So today I'm going to talk about why you would want to depopulate a head. And then after that, I'm actually going to go through the process that a user would follow to depopulate a head. And then we'll talk about where to go from there. So the case for populating a head, the hard drive is a fault-tolerant device, and we find that when transmit packets are corrupt, they're retried. When data goes bad, it's recovered using error correction. When regions of the media go bad, sectors are relocated and the device continues to run. So fault tolerance is now expanding to include failing heads, which are larger regions of the media. This capability is in its infancy and it's growing, but this is the first way that has actually been deployed that I'm aware of in a standardized way. So we are looking at basically not just keeping a drive from going bad. We're looking at taking a drive that you would normally remove and keeping it in chassis. So today, when a head is going bad, you yank the drive. You'll usually get a smart trip or a device fault or an internal hardware error. And when that happens, you have some costs associated with it. The associated cost impact of removing and replacing a drive is actually kind of expensive when a tech has to visit the system and put in a replacement. Or maybe you've just got a big bunch of stuff at home and you've got to spend a couple of hours taking it apart and putting a new one in. But in addition, in the data center, there is an associated cost impact of regenerating the data. So while you're regenerating data, whether it be that you're in a data center with an erasure coded system, or you're even in a RAID, data is at risk while it's being regenerated. This may get worse if you're unlucky and have multiple failures that affect the regeneration. There's also additional power costs for replicating the data throughout the data center. There is, in addition to that, associated cost impacts associated with network bandwidth usage. So if you take, let's say, a 20 terabyte drive offline because a head goes bad and you put a new drive in, you're going to sit there and want to put 20 terabytes of data, which means you're reading 20 terabytes from the various drives in your data center and writing the additional 20 terabytes onto a hard drive. So when a head is going bad, another way to handle it is to reformat and refill. So this is standardized and deployed. It means there's no tech visit. So in your data center, what we see is that people don't fill their drives to 100% very often. Most of them have a margin requirement. And so in my hypothetical 10 platter drive, a head going bad is 5% of the media. And what we see is people leave 5 to 10% of the storage capacity unused as a general principle. And what that means is when a head goes bad, you have some margin for removing a head and continuing to use the drive with the data that remains. So there's no tech visit. You could save the good data elsewhere, protecting the integrity of the data. And in the case of a write head failure, all the data on the drive remains good. So only the bad data, if any, needs to be regenerated. So as we move forward, when a head is going bad, and I think Ralph is going to do a presentation on one way to do this after I complete mine, the good data does remain accessible on the drive. And if failure was a write head, all the data can be read. And if the failure was a read head, of course, then 5 to 6% of the data is lost. However, the host can avoid the failed write areas and the data in those areas can become read-only. The drive could become thinly provisioned and make all the sectors remain good. And then the host would need to deal with the errors associated with the media running out. So this is work that's actually in process right now. It is not yet standardized. It's forward-looking. But this is what we have to look forward to, and we are encouraging future discussion in this area. So modeling the drive failure rate with head depop. So drive failures can be split into two groups: head-related failures and total device failure. So head-related failures affect individual heads and can be addressed by removing the failed heads, which is offline depopulation in this case. These total device failure, of course, will cause complete loss of the device. So if you have, let's say, we'll call it a head touchdown under the media, it might throw debris up into the device so that it is unable to be recovered. What we find is up to 80% of the total failure rate is head related and can be addressed by depopulating failed heads. So I'm going to show a plot on the next page, which shows the results of an analytical model with simulations with and without single head depop. With 18 heads, the head-related annual failure rate is taken as 0.8%, and the device failure rate is taken as 0.2%. So this is the drive failure rate. So what happens is that if you just yank the drive as you do today, over 5 years, you see that you're going to get a considerable number of failures. If, however, you allow one head to be depopped in your system, then the drive time in years and the number of failures you get goes way, way down. And that's just for one head failure. You could allow two heads to fail. It depends on how fault tolerant you want to be. If you're in a data center and slot uptime is important to you, some wait, for a drive to fail, and they want more than one drive to fail. So you've got a data center with, multiple drive failures, and they send a tech out once every couple of weeks to go replace failed drives. And so in that case, the slot would be down for a couple of weeks, which has a very major impact on your uptime. With offline head depop, instead of being down for a couple of weeks, it could be down for just maybe a single day. So this is the overview of how depopulation works. ACS 5 calls this storage element depopulation, the storage element depopulation feature set. And I've put a reference in here that you can go download the standard, standard under development. It is publicly available, and look at that section. So what we're saying here is a head failure really no longer equals a device failure. The device statistics in a SATA drive has something called physical element status changed, which indicates that a failure has happened. And when you see that change, you can issue a get physical element status and find what the failed head is. And if you really want to be fine grained on it, you can also poll frequently to find that information. You could use rebuild assist to recover the data. If the failure was a write head, all the data can be recovered and there's no need to use rebuild assist. Next, you would use the remove element and truncate command to reformat the drive to a smaller size. A 9-platter drive has 18 heads, and one head failure equals a 5.6% reduction in capacity. So the drive is then offline about the same amount of time as a format command, and then you can begin using the drive again. One thing I would like to note is that the paradigm is changing a little bit, and instead of looking at a head as being both the reader and the writer, these are being separated now. You can't take the reader offline separately from the writer, but of course you can use the reader before you take the head offline, which gives you the ability maybe to just keep running and let the data be read-only. At any rate, this whole process probably takes between 5 and 10 hours today, and you can begin reusing the drive again at the reduced capacity and avoid the tech visit. So we now have this form of offline depopulation already in place and standardized. We're trying to discuss the most efficient and universally accepted method of keeping high capacity hard drives operating in the field to maximize the reliability of deployed storage. We've been looking at a variety of environments, including things like set-top boxes, where there's considerable expense in sending out a replacement when the hard drive goes bad. We're talking about RAID systems, which the longer it takes to get a spare regenerated, the more your data is at risk. And we're talking about slot uptime in data centers. So moving forward, we're looking for more applications, and we're looking to work with partners in deploying this new capability. In closing, I think we should consider how keeping a drive in operation, possibly with reduced capacity, could affect overall data center integrity. It also affects server and system reliability, and it has savings of maintenance cost. So I'm looking to see if we can agree on a universal method of keeping a drive in operation. Is there value in doing an online version with less data movement? So on this point, there's been discussions on doing online depop. And what we're finding is several companies are just looking at offline first and online for the future. And we're looking at the best methods to do it. And we are calling for open discussions on industry consensus on the most efficient implementation for in-field head depopulation. And that's it. I guess I ended 10 minutes early.
Curtis, can you hear me? This is Bill Boyle.
Yes, Bill.
Yeah, I had a question with regard to the applications you were mentioning, specifically a set-top box or devices that there's only one drive present. Does this really work in those type of applications when there's only one drive?
Well, it depends, right? So if you have a package, a deployment package that's maybe on areas of the media twice, where it occupies 2 heads, you could, as a part of the activity, protect it and make it so that you could run the redeployment package and bring it back up.
Oh, if you had some sort of mirroring, you mean?
Well, let's just say that when the system is fresh and you turn it on, it goes through and does its OS install and all the things associated with it somehow, right? And if that material were either stored in the system somewhere, or it was on the media under multiple heads, then you could say you could redeploy it and continue running. So sometimes what we see is, okay, so at home, okay, I'll just go with my little server box implementation. I have a WDDX 4200, which is a very nice little server box. And it has crashed completely on me a couple of times. And somehow it's managed to restore itself. And it reformats everything and you lose data, but it continues running and there was no tech visit necessary. So I believe that in the set-top box, once the hard drive, corrupts your data, sending a tech out or sending a new set-top box is expensive. But if the set-top box had a recovery capability where it could depop the offending element and it could reinstall the OS onto the hard drive, you're good to go. And those elements are not very large in a set-top box.
Okay, thank you.
Right. Now, I will go out on a limb and say that online Depop, which Ralph is going to present the first version of it coming up next, would definitely keep things running.